the right side as well. The whole thing is the proof. So there's left and right side of the proof, but yeah, we do need to fill out some reasons. I do want to just kind of make sure that we're on the same page though. Does anyone have a question they can articulate, even if it's a partially formed question? We need to try to raise the level from like wherever you're at, you know, up a notch if we can.
I know how to do the algebra. It's just I have no clue what to put on the right side of the graph.
Okay, good, thanks. Yeah, we're going to tackle that next. I just want to make sure that we kind of do a check-in right now on the left side. Does anyone have a question on the left side as to what's going on with one of the steps?
Good.
Yeah, so let's, this is what I want to do as far as the right side goes. I think some people are still kind of looking over the left side, which is fine. But yeah, let's start talking about the right side. We have 10 minutes left in class, and I really want to raise the level on this problem because it'll help us with all of the problems. What's happening with the first line up there? What's going on? I have given written. Do you know why I wrote given?
Because that's what they gave us to solve or prove, I guess. Use to prove.
Yeah, that's what where they want us to start the problem. I think before we talked about proofs being like a treasure map. They give you a start and where the treasure is, but you have to find your way there. So the given is just the problem that we're trying to prove the answer to. What's happening in the next line down?
Multiplication property of equality.
Yeah, that's the official name, multiplication property of equality. And so we can write that in shorthand. If you were just to describe what's happening without using a property, just in your own words, what would you say is happening there?
Multiply -5 on both sides.
Yeah. Yep. We're multiplying a -5 on both sides. Why would we do that?
Because it works as an equalizer, I guess, and it's easier to solve if that's done.
Yeah. When you say it works as an equalizer, that's language I want to unpack a little bit. Someone else add to what Lucas just said. It says it works as an equalizer. Is it you're talking about here?
Yeah.
Yeah, what's going on here in particular?
It creates a ghost one.
Yeah, it creates a 1. Why? Like, why does it work so well?
Because we don't like fractions very much.
Yeah, well, yeah, you can kind of get rid of fractions, can't you? I mean, I think you've all heard that anything over itself just equals 1, right?
Yep.
Yeah, so we use this to our advantage all the time with algebra. It makes fractions way easier to think about and handle. So once you learn this right here and how you can use it, then fractions become a lot less scary. So like when we started out here with a -5 on the bottom, that's like this here. I knew that if I multiplied the top by 5, I would have a -5 over -5, which is just a 1 times the rest of that business. Okay, so multiplying the top by -5 gives me a 1. It gives me really a 1 times 3x plus 2. But do I have to write the 1? I don't really write the 1, do I? I just leave the 1 off right there. I mean, there is a ghost 1. That's why we call it a ghost 1, because you don't have to write it. There is a 1 times that business there. Okay, so that's a really good way of just taking care of a fraction. So what? Yeah, we multiply by -5, but we have to do it to both sides. That's why it's a property of equality. It's because we did something on both sides, and its multiplication happens to be what we did on both sides. Okay, what's happening in the next step below this?
Substitution.
Yeah, it's another word for simplification. You know, we took this piece right here and we just substituted it to make the problem look simpler, right? We also substituted this mess, this 1 that we created, we substituted that for 1 times 3x plus 2, but we didn't have to write the 1. Okay, so thanks for the feedback, Nate. I see you. This is just simplifying the previous step. And then what do we do next here? Well,
substitution of property.
Yeah, I did substitution between here and here, so I write substitution. But what do I do here? Just describe in your own words, what do you see happening with this step?
Substitution, property of equality.
Substitution?
Leave it on both sides.
No, that's up here. This is substitution when we change from here to here.
Addition.
We're subtracting from both sides, so.
Yeah, subtracting from both sides here, right? So that's what we're showing in this step. So if we do it on both sides, what do we call that?
Subtraction of property of equality.
Yeah. Notice how I use a SUBT so it doesn't look like substitution. So this is subtraction and this here is substitution. So subtraction prop of, so this is an accepted shorthand. Okay, good. And then everyone good with this? We removed this +2 from both sides. What happened between here and here?
You just added the 2 to -3.5.
Yeah, I just took this and I put it in a simplified form. And I took this, instead of doing a +0 here, we don't have to write that. So I just did this as simplified form. That's called substitution again. So in the book, it's not always going to show the substitution steps. Sometimes we just do that in our heads. But in this lesson, I'm trying to show you everything so you understand the properties. Everyone good with this being a substitution, changing from this to this?
Mm-hmm.
Okay. And what's happening here? Just describe in your own words.
Dividing 3 to create a ghost 1.
Yeah. Do you see how we do kind of the same thing here that we did up above? Is we have this and we want to make a 1x. And so we divide by the same number because anything over itself is 1. So it really shows what we're trying to do here is make a 1. And we do it on both sides. So that's an equality property. What do we call it?
Division, property of equality.
Yep. Okay, everyone good with the division property of equality? We divided 3 on both sides to create a ghost one here. Did we have to write the one?
Nope.
Exactly, right. We didn't have to write it. It's a ghost one, so you can just leave it as 1x is just x. So, you know, when sometimes things seem to just disappear in math, like, you know, these -5s seem to disappear. Well, they were actually, they were turned into a 1, and we didn't have to write it. Same thing with this. We could have written it as 1x, but we didn't have to. Okay, so now we have x equals -12 and 1/3. I mean, this I had to produce on my calculator to go from this to this. I mean, I probably could have figured it out, but in my calculator, it was -12. I actually got this on the screen. But if you have 3, 3, 3, 3, 3 repeating, that's the same as -12 and 1/3. So that's where that came from. Okay, we have 1 minute left in class. Okay, and so I really hope going through this problem has helped you understand kind of what to write on the right side. Now, one student requested that we look at number 18, and so I'm just gonna do this. Okay, that's what 18 should be like, and I'll post that online so that you guys can take a look at it and check your work. Okay. Class is going to end here. Thanks, guys. And, you know, if you still have questions, you know, shoot me some feedback. I'd like you to try to finish this assignment if you can before Monday.